Hello and welcome to this clip looking at how to construct a full balanced equation and an ionic equation starting from a description of the reaction and the word equation provided. So the recall required is basically a working knowledge of your ions and their formulae, the common ones in A level. The ones that are relevant are magnesium 2+, nitrate NO3-, and carbonate CO3 2-. So nitric acid has the formula HNO3. And finally, when constructing ionic equations, only the aqueous species are split into their ions. All other state symbols are left alone. So looking at the first paragraph, it gives you quite a lot of clues as to the state symbols you need. So a solution of magnesium nitrate would be MgNO3 2 and then aqueous in brackets. There are two nitrates because nitrate is a 1- ion and magnesium being a group 2 metal would be a 2+ ion. So then it says solid magnesium carbonate. So this time carbonate is a 2- ion, magnesium is a 2+ ion, so you need one of each. And it's a solid, so you therefore put S in brackets afterwards. Dilute nitric acid, the word dilute suggests it's in solution, so you use HNO3 with an aqueous next to it. That's how you work out the state symbols that are required. So constructing the overall equation, this is what we end up with. Obviously it says a gas is also produced, which turns lime water cloudy. So I would expect that from GCSE you can remember that that's going to be CO2. And what's left behind is obviously H2O, water. Now the equation needs to be balanced, so the easiest way to do this is to start with the most complex species, because this will have the greatest influence on the balancing numbers elsewhere in the equation. So obviously that's going to be MgNO3 2. So the thing to do here is to look at the two nitrates present, and if we go to the left-hand side, there's only one. So that means you put a 2 in front of the nitric acid, which we're going to do now. At the same time, what that does is it solves the problem of there originally being one hydrogen there and two hydrogens in the water. So now the water is balanced. So doing a quick check of all the different atoms on each side, you can see that we're now balanced. So the next thing to do is to construct our ionic equation. Now remember, the only species with aqueous ions are changed. Everything else is kept the same. So what we do is we split anything with aqueous after it into its constituent ions. So putting the equation down at the bottom, you can split the HNO3 into two H pluses and two NO3 minuses. You can split the magnesium nitrate on the right-hand side into Mg2+ and two NO3 minus. So now you cancel anything appearing on both sides, so that's obviously the nitrate ions. And everything else can be grouped back together again, and that gives you this. So you can do a quick check and see that we're still balanced for a species. Okay, so thanks for listening. Until next time, see you soon.